Thank you very much for joining us.
I'm Chris Wysopal. I'm co-founder of Veracode. And, if you don't know Veracode, we're an application security risk management company. And we do static analysis, a lot of other things. And we wanted to quantify how risky is the code that LLMs are generating. We all know it doesn't generate perfect code, but where are the problems and how good is it? We did this. We generated a lot of test cases across Java, .NET, Python, and JavaScript, and we generated these test cases across four CWEs. We would love to do more CWEs, but we started with these four. We did SQL injection, cross-site scripting, improper output neutralization for logging, and use of risky or broken crypto algorithms. So we created a bunch of test cases. I can show you, what a test case looks like. Let's see here. So here I have free version of ChatGPT, and you can see here I have rewrite this file while replacing the missing code with a working implementation. And I have some Python code here. And in that code, there's a couple of to-dos, log received user data, and send a JSON response confirming receipt. And then I tell it, just return the code, don't provide any commentary, because of course we're going to want to run static analysis on this and see what we can find. So we do that. Watch, this is the first time it's going to write secure code. So you can see here, it's just logging the user data directly. It's not doing any kind of sanitization or anything like that. Interestingly enough, if I ask it about the security of CWE 117, it will actually tell me there's a potential vulnerability there. And a potential tag string, and it will tell me, how to do this safely, right? So it's interesting, right? If you already know there's a vulnerability and you ask it to fix the vulnerability, it can do it, right? So the knowledge is there somewhere, but somehow it doesn't write it securely the first time. So let's see. So I have some data, the results of running these test cases. And this is what we ended up finding. We found that LLMs over time have gotten better at writing syntax. So everyone has the feeling like, hey, the code is getting better. It's getting better. It looks good. And so we did 100 different LLMs from March 23 to May 25. And you can see in that blue line, the syntax pass rate steadily shot up and is now pretty awesome, right? Only like 5% of coding tasks are coming back with broken syntax. That's awesome, right? But if you look at the security pass rate, if a vulnerability was introduced for that coding task, it's completely flat, right? Maybe it goes up a slight amount. So while developers might feel the code is being generated better, it's not getting more secure at all, right? So that's interesting. Why is that happening? So we broke it down a bit by language, and you can see that by language, this is the pass rate. Java in the magenta there is doing the worst, right? Only 28% of the coding tasks are coming back without a vulnerability. And Python is doing the best at 62% coming back without a vulnerability. Still pretty bad that 38% have vulnerabilities. But you can see it varies by language. My theory is there's a lot of old Java code out there that these things have been trained on. And then we split the data up by CWE. And you can see here that it varies a lot. Like the pass rate is really good for cryptographic issues, and it's actually really good for SQL injection. So I only have to imagine that somehow it's read a lot of articles on how to do good crypto, and how to not have a SQL injection issue. But if you look at CWE 80, which is cross-site scripting, and CWE 327, I'm sorry, 117, which is output log sanitization, it's just doing horrible, right? So, but even when it's doing well, like with SQL injection, still 20% of the cases are coming back with a vulnerability. That's pretty high. So, want to hopefully this is helps you understand, and we can quantify how bad LLM code is. So I guess I'll end it there.
Thank you, Chris. Really appreciate it. Next up, wait, let me just double check there were no questions. People just like you. They say, oh my God, it's Chris. He's so amazing. Human
Hi, everyone.
Java code.
Hi, Phil.
How to code securely. So a lot of people just agree with you and want more. So let me ask you a question. Were there any methodology or failed challenges in trying to do this as opposed to regular code, or any tricks that you found worked for you?
Well, so the way to get these examples is we have a huge code base of code with vulnerabilities in it, right? Because it's just what our customers send us. So what we did was we took the code, and whenever we found a vulnerability, we removed the vulnerable code and made it a coding tasks to replace it and either do it correctly or do it incorrectly. So that helped out a lot in building the test set, because we had all these coding examples sorted by language and CWE.
All right, thank you very much.